Just let me get to the correct place in our notebook. We have done quite a lot already. Let's continue with the topic of dictionaries, which are a collection of key value pairs. Keys are unique in a dictionary. A dictionary is like a small database. You can store some values in it if you assign them a name, a unique key. Dictionaries can be used, for example, for counting the number of times various words appear in text, so text frequency. So dictionaries are defined using these curly braces. And this is a simple dictionary which consists of keys with assigned values. So country Latvia, key city, colon Riga. And then we can ask the dictionary for a value if we give it a key. And Python finds out that value corresponding the key city is Riga. We can also assign values to a dictionary later on. Here we defined a dictionary that already contains some values, but we can add more values. For example, say that value with the key food equals potatoes. And now we have a dictionary with country, city, and food. And dictionaries are good in that you can access their content very quickly. So food is potatoes, country is Latvia, and we can ask a dictionary for keys and values as well. So keys will give you a list of keys in a dictionary, and values will give you a list of values in a dictionary. You can use the in command as before to check if some value is in a dictionary. So we can check if potatoes is in values of this dictionary, and yes, true it is. We can also check if some key is a part of a dictionary. So if country is a part of a dictionary, yes, that's true. Now, we can even record more complex knowledge as dictionaries, because the dictionary can contain not just simple values like text strings, but a dictionary can also contain, for example, Python lists. So we have a list of countries, which we have a key countries, which corresponds to a list consisting of two more dictionaries. So dictionaries inside dictionaries is also possible. Let's see how we can access these values inside the dictionary. First, we may want to use a function pprint, which we have to import from a library called pprint. And using that, we can display our dictionary in a bit nicer form. So we see more clearly what value corresponds to the city's key and what values correspond to the country's key. Then we can ask a dictionary for whatever value corresponds to the key countries, and we get back a list about Latvia and about Estonia. Now we can go further and look inside this list to get the first element, so the element with index 0, and that is this part here, that is country Latvia and food potatoes. And then we can go dig further in and get the value corresponding to the key food, potatoes. That much about dictionaries. And now about tuples. some of you managed to already create tuples by putting a number of values separated with commas. So you can, the tuple is a sequence of some values. It cannot be changed later, but it's useful in some cases when Python requires the value not to be changeable. So it's similar to a list. For example, here is a tuple containing values 6, 4, 9, but it cannot be changed. We can also define a tuple just using commas, but I would suggest to use these parentheses as well. And then we can access elements in a tuple, for example, element with index 2, but we cannot change the values of a tuple because it's immutable, it's not changeable. And tuples can be useful as dictionary keys. For example, if you have dictionary keys consisting of a date, you might write a tuple consisting of year, month, and day. Or tuples can be useful if we will need to return multiple values from a function. We'll look at functions later on. So the next topic to cover is flow control. And with flow control, we tell Python how to execute some parts of the program. And before we can look at the if command, which gives Python the ability to choose one or other thing to execute, we need to look at comparison operators. And there are a number of comparison operators, which mainly are kind of mathematical: larger than, less or equal, larger or equal, or if we want to compare some values, if they for equality, we have to use two equal signs. That's because one equal sign is already taken by the assignment command. And if we want to check if two values are not the same, then we use exclamation mark equals combination. And then there are also logical operations and, or, and not that combine Boolean values together or invert them. And here we compare if 2 by 2 is 4. Yes, it is. If 5 is larger than 7, false. It's not true. Let's print the comparison if int of 5 equals 5. And also let's print another comparison, result of a comparison, if 5 is less than or equal to 6. And these print commands both print true. Next, we can check some more conditions, and here I will use not equals sign. So 5 is not equals to 6, so this should be true. And 5 not equals to 5 should be false. Let's execute this and see the results: true, true, and false. We can also compare text strings, and they are compared based on their character codes. So we can check that, for example, text Uldis is less than Valdemars. And to see why that is so, we can use function ord, which gives us the code of the character. And the code, the number of character V is 86, and both these strings start with V, so the next letters are compared, O and A. And the code for A is 65, and the code for O is 79. So Valdemars is larger than Uldis. So what else? You saw already before that we can check a string if a substring is part of a string, say UL, capital letters, are a part of the string Uldis. But if we put L in lowercase, then it won't be true. We can also check if some value is in a list. We looked at that before. And we can use commands and or not and not to combine multiple comparison values together. So that's kind of a crash course on comparisons. And now when we have comparison operations, we can look at conditional execution. That lets the program choose what parts to execute and what parts not to execute. For example, here, okay, so that's done using the command called if. And we write it that way: if, then some condition, something that can be converted to a Boolean value, true or false, colon, and then we continue with a code block that starts with some spaces, that has some spaces before the commands, so that Python will know if there are spaces before these commands that they belong to the if command, and this code block, this combination of commands, will only be executed if the condition is true. So, for example, if 4 is larger than 5, then this program would print, oh, 4 is larger than 5, wow. But that's not true. So this code block here will not get executed because 4 is less than 5. And when the code block ends, you just write commands without space in front of them. And so Python knows that this command here is not part of the if command before that. So let's execute it, and it will only print the output of this command here. And now you may ask, does it matter how many spaces are put in front of commands in this code block? It does not matter the amount of spaces, but you need to be consistent in that. Here I use 4 spaces. Sometimes people also use 2 spaces. So something like that. That's a matter of taste. And here are some more comparison operators. So 3 if commands. 5 is larger than or equal to 5. That this prints out hello. 5 is not equal to 6, so that's false. And text hello, that's magic, will not be printed. And 5, it's true that 5 doesn't equal to 6, so this one will get printed. Now, what's wrong with this code? Okay, I used extra quote in the text, but let's move on. We can check for inequality using not equals, and we can use that for text strings as well. Or there is another way to write this using the not command. This will check that Uldis, that the condition Uldis equals Uldis is not true. So this not reverses the Boolean value to true, because it's true that Uldis is not equals to Uldis. Okay, so what we have here is code blocks, is if command with a condition, with a colon, indicating that a code block is following, and then some commands that are executed or not, depending on the condition of the if block. Now further on, we can also compare variables. So we can check if a is larger than 5, print something, and we can add the command else to the if command, and in that case, if a is larger than 5, the first code block will get executed. Else, so otherwise, if A is not larger than 5, the other code block will get executed. And this text here is printed out. You can also use elif command in this execution, in this Python code. And elif means else if. So it checks if x is larger than 45, else if it's not larger, then it checks if x is less than 42, sorry, 42, not 45, and else, that's a condition, if no previous conditions are met, prints something else. So let's enter 43, and we get this part executed. Now here is some code for entering temperature in Celsius, and we get back Fahrenheit temperature. So if we write 37, then Fahrenheit temperature would be 98.6. But what I wanted to demonstrate here is that we have an if statement, if command, that checks if Fahrenheit temperature is larger than 100, then it suggests to find the doctor. Since it's not 100 or more, then it did not print this, text. Next one is loops. And the loop allows us to perform the same or similar action multiple times. And there are two types of loops, a while loop and a for loop. And while loop gets executed, so we have a command while, and we have a condition here. And the while loop gets executed until the condition becomes false. So while the condition is true, while I is less than 5, this code block here will get executed. So it will print talk, it will print I is, and the value of I. And then we will add 1 to the value of I. And what happens is it prints Alice did, talk, I is 0, 1, 2, 3, 4. When I is 5, this code block is no longer executed because, well, 5 is not less than 5. At the end of execution of this command block, I has reached the value of 5. But if you want to just go through your program, say 5 times, like here, counting from 0 to 4, a for loop is better suited for that. So a for loop instructs Python to execute the code that is under the for command, so after colon and with some space in front of it, while for every value of a given sequence. So in this case, range 10 will give us numbers from 0 to 9. And let's see how we go through or iterate through all the values in this range 10 sequence. And we see running the cycle, printing 0, and so on, until we print 9. We can iterate through lists, through strings, and so on. For example, here we will print Uldis, every letter in the word Uldis. We can iterate through list elements as well. And again, we write for some variable name, item, in the list food. And we will print all the values. Here is the same. The variable name doesn't matter, but you can use that variable then in the body of this for loop. So we will go through the shopping list, which now has also chocolate and strawberries, and it previously contained kefir. So we go through this sequence, this list, and for every item in the list, we execute this print command. So that's about the print command. And we can also go through a dictionary, through values in a dictionary. Here, if we want to go through a dictionary, one way how to do that is write it like this: for key, comma, value in my dictionary dot items. And then for every key in the dictionary, we will get the value of the key in the key variable and the value of value in the value variable. And let's see what's in my dictionary. The key is country and the corresponding value is Latvia. The key is capital and the corresponding value is Riga. So here you can see how we can go through items in some sequence, in a list or in a dictionary, and print them out. And here I had an exercise for you to do, but let's do that together. If someone feels that you can do it by yourself, then go ahead and do it, not looking at the screen. But to save time, as the time moves faster than I would wish it would, then I'll just show you how to do this part. So the task is to write a program that counts the number of different words in a text string. So we want word frequency. And we want to display the top 10 words and the number of times they appear in the text. So first we need to split the text into words. Gemini is trying to help me here. Now we define an empty dictionary using curly braces. Now, yes, indeed, I had the code written like this as well. Gemini is already helping us here. So for every item in the words list, so for word in words, we check if the word is already present in the results dictionary. If it is present, then we take the value in the dictionary and use the plus equals command to increment this value by 1. But if it's not in the results dictionary yet, then we assign the value 1 to the key word in this dictionary. And if we now print the results, okay, I'll use the print command, then you can see that we have a dictionary. I will use pprint to print it in a bit nicer way. So we have a dictionary with words as keys and values as dictionary values. So now we need to figure out how to display top 10 results. And to do that, okay, let's accept help from not the audience, but from Gemini this time. So it already constructed quite complex Python code, but basically we go through all the values, all the items in results dictionary. We instruct Python to sort by item, by the second item, second part of the item. So we have keys and values. And results.items give us keys and values that are present in the dictionary. And we instruct Python to sort by values, not the keys. We instruct Python to reverse the result, so the top matches are at the top. And we use the slicing syntax to get first 10 results. And then inside the cycle, we just print key and corresponding value. And let's see if that works. It would have taken you probably more time to do this, but since we got help from Gemini, here is the result. And the in is off for it, and so on. So this is the resulting code for calculating word frequency. I'll leave it on the screen for a bit. Are there any questions or something that?
Sorry, what was key lambda?
What is key lambda? Okay. So basically, when we go through all the items here, we have pairs of key value, and this key equals lambda instructs the sorted function what to use for comparing two values. It tells us that we want for every item in the list of items in results dictionary that the key for sorting these elements should be element number 2. I will show it briefly here. So results.items give us pairs: natural, 1 time, off, 3 times, and so on. So we are getting a list of tuples, which and we want the sorting to happen by the second element of a tuple, the count of the times the word appeared. So this lambda is a Python construct which gives us a short way how to define a function. So we define a function that takes an item and returns the second element of the item. So, well, basically, it instructs sorting to sort by numbers of appearances. But if you have further questions about this, and I realize that this is maybe a bit more complex code, see what ChatGPT says. That can be an addition to my explanation. Just ask it, explain this code. And it might offer something useful or not, depends. Let's see, explain. And it starts explaining what this code does. So that's one way how to get help. Okay, are there any more questions about this part? So what else do we need to cover? I mentioned functions already before. So functions are some block of code that you want to use multiple times, usually to perform some single related action. And functions that follow the dry or do not repeat yourself principle, that we don't want to repeat once again and again and again the same code. If we want to use the code again, we define a function. So we put some actions inside the function, and then we can call this function whenever necessary. Are there any questions regarding the previous part? Let me know if there are. Okay. We will look at another way of finding out word frequencies soon enough. Let's get to that. So let's define a function. To define a function, we use command def, give a function a name, and then put arguments in these round brackets, parentheses, yes. Put a colon, and then write the code inside the function as a code block with some space in front of it. For example, here we will print two things. When you define function, nothing yet happens, but these print commands are executed when you call the function. To call the function, we write function's name, parentheses, and any arguments that it may have. In this case, our function doesn't have arguments. And we call it, and it says running my first function. We can call it 3 times, and we will get running my first function 3 times. And we can give arguments or parameters to functions. For example, here we give the name parameter to a function, and then we use that name inside the function body. And then we can call this function repeatedly, and it will print maybe my name is, and whatever we supplied as the name argument to the function. So we can print maybe my name is Uldis, maybe my name is Sergey, or maybe my name is Introduction to Python. So we can define whatever functions we need, and then we can reuse them. For example, here is a fictional function for making text in alternate letters. So it goes through all the letters and puts every other letter in uppercase. But it doesn't matter what this function actually do. What I wanted to show is that functions can return value. So in this case, a function alternate letters takes an argument, some text. Here we supplied it. It constructs a new string variable containing what it wants to return, and then at the end of the function, we have a command return and some value. And this way, a function can return value back to us, which we can print here in Jupyter Notebook, or we can assign that returned value to some variable. And so we call the function, and here is the result. Are there any questions or? No questions so far. It is a good practice to also describe what the function does. So if you define a function, then it's good to write just briefly that this function, for example, returns a multiple of first 2 arguments. And if you write this string here at the beginning of the function, then when you ask for help, it will tell us returns multiple from first 2 arguments. So that's another helpful thing to do if you are defining functions. Let's see, we called this function mult with 2 arguments, a comma b, and it says, look ma, I'm multiplying. and indeed it returns 15, which is 5 times 3. Let's see. We can also, of course, have flow control inside the function. So the function can have 4 cycles, while cycles. We can put if in the function, and so on. For example, here we take an argument number, and we compare if the number is larger than 10. We say this number is too unwieldy for me to print. And if it's less than 10, then it's a nice number. Here as well, just to move forward, I will define this function for you, and I will leave it on the screen for some time, because we have still many things to look at. So here the task is to convert the program that counts the word frequency into a function, so that we can call it a number of times. And the way how we can do it, it shouldn't be too difficult, but we need the previous code that we worked with. So here is the code for displaying top results, the most frequent words in some text. I copied our solution, and I will try to make a function out of it. And it should not be too difficult, because we have already written the code. We just need to put it inside the function now. So first thing we need to check is we have the argument named input text. So we will use that argument in the split command here. And now we just need to add these spaces. For some reason I have 3 spaces, but it shouldn't really matter. Let's see if I can define the function. So what happened, I took the code that we already had, and I converted it to a function by taking the input argument, input text, and using it inside the code, and putting these spaces in front of these commands, so that we tell Python by the space from the left-hand side that this all code belongs to the function body. So basically that is the function that we defined. And now let's check if we can run this function. And somewhat to my surprise, it works. I expected that maybe there would be some errors, but no, we give text as an argument to the function, and we call the function top 10 words with this argument text. That argument text gets input to the function under the name input text, then it gets split into words, and then we use a dictionary to build a database of words and their frequencies. So you can see how a dictionary can be useful for collecting some data. And then I use this command suggested by Google Gemini to print out a sorted list of top 10 results. I leave that on the screen just for a bit, and we'll be glad to hear your questions if there are any. Okay.
Sorry, I think I still don't understand the step 3. Like I couldn't write it myself. Could you maybe translate it in natural language?
Which part?
Step 3, display those top 10 results and the function that comes after it. So I understand that the second step is like mapping onto the results, right? And if there is already something which has this key or value in the key, then it has one number, and if it isn't in the list, then it in the list of results, then it adds it to the list. But what happens in the third step, I don't quite understand.
Okay. Let's see how we can. So the question is that that it's unclear what happens in the third step, right? Okay. So we need to sort the values in reverse order. And to do that, we also need to, so it's helping me already. We do that using the function called sorted. We give it a list of things we want sorted, results.items. We tell it that we want the sorting to be in reverse order, so higher values come first. And now the question is probably about this part. So we need to specify what to use for sorting, what part of the data to use for sorting. And if we did not do that, oops, close. Let's see what's in results. So results has some values, and we are asking for result.items. Oops, sorry. And that is a list of Python data structure called tuple, which consists of two parts, the word and the frequency. And what we do with this command, key lambda item square brackets 1, is we tell it that we want it to sort by the second element of every pair of word and frequency. So what happens is we indicate it what part of the data given to it to use as a key for sorting values. And maybe let me show you what happens if we don't have that key part. That could perhaps help resolve it. So I will remove the key part, define the function again, and now when I print out the results, these results are sorted by alphabetically in reverse order. And we need to somehow instruct Python that we don't want to sort by the name, we want to sort by the value. And that lambda part defines a function that gives that returns a value to sort by. This lambda is a Python construct that is a short way to how to define a function. We could have defined a function get sort key item we could have we could have done it. So basically, we need some way to tell Python by what part of the value to sort. That we got that far. And then we supply it to the sorted function. We supply it some code that extracts, that is getting this pair of word and word frequency, and extracts the word frequency part. I don't know if that makes it more clear or not, but this should work same as before. So fox appears 3 times, brown appears 2 times, and so on. Does that help or not at all? Okay, I hope. Yes, but you will see further on that you will not need to write this particular code, as Python can do it for you. So let's look at Python libraries. Python libraries are part of this Python batteries included philosophy that we don't want you to actually reinvent the wheel, and counting things is something that maybe somebody has already written code for that. So and in Python, the code that is already written for us is organized into libraries. So we have a library of useful functions, useful constants, and so on. For example, if you need some mathematical operations, you can import the math library, and you can also ask for help on this math library. And Python helpfully tells us that we can get logarithms and whatnot from the math library. For example, we can ask what's the cosine of 3.14 by using the library name dot and the name of the function in this library. So we get cosine, we get constant for pi, and we can check that cosine of pi is -1. There is also a library called random that generates us random numbers. For example, we can call a function from the random library by writing random.randint, random integer from 1 to 6. Basically, we're throwing the dice. Or we can do that in a cycle, repeat it 10 times, and print 10 random numbers, 6, 1, 6, 1, 3, 1, 3, 3, 2, 5. And here is help about the random library. And now one more built-in, so all these libraries are built into Python. So when you install Python, you already have these libraries available. So you can do something with them. And one of useful tools in these libraries is counter. So counter lets you count items. And so you will not need to write this sorted by lambda key part yourself. I needed to show it to you how you can do it by yourself, but here let's try to use the counter instead. So we write that we want to import the counter from the collections library, and maybe let's look for help about this counter. And we get information about the counter class, which starts somewhere here. So it says that it's for counting items. Basically, it's a class for counting items, and the help also has some examples of how you can run counter. Let's skip the help and just try to count the number of letters in this text. So we have text abracadabra. We create a counter and we give it parameter of this magic text. And then when we ask Python to show us the counts, it tells us that there is a counter object, a Python data structure, which knows that A was appeared 5 times, B appeared 2 times, R appeared 2 times, and so on. And here you have a method. So this counter has a method called most common, and we can ask for 5 most common items. And then we can use a for cycle to print them in a maybe a bit nicer way. So that's something. Yes.
These are very short and simple lines and like a few data, but if we have like a large data, how can we, I don't know, insert this document, or how can we use it for analysis? Or it's a question for another day.
Well, that's a question for, I guess, part about NLTK. And, well, I was hoping to cover it today, but we'll see how far we probably won't get that far. If you have large texts, well, first, I would use the Natural Language Toolkit library for that, NLTK. If we don't cover it today, we'll cover it tomorrow. But for large texts, you need a way to get these texts into the program first. So for that, you need file operations that let you read a file or a number of files. And then once you have got text from the files, then you can use it similarly as we do it here. What do you want to do with that text in particular?
For example, I want to like count, I don't know, the 10 most frequent words or phrases in the text. Like the same task. How can I? Because obviously we are not learning it to count letters in a word.
Yes, that's true. So to count the number of words or tokens in some text, we could also use this counter object here, or we can use the tools of this Natural Language Toolkit. And let's look at that a bit later. So first step would be to read, well, basically, you probably the texts that you have in mind, you can read them in memory. They are large, but not that large. So you open the file, you'll read text from the file, and then you can split this text, run the counter on it, same as we do here for simple letters.
But how can I insert this text here? Or where?
How can you work with your text, right?
Yeah.
I will look at that in the final part of this notebook, working with files. Yes?
A question about counter. Does it count the letters only, or can you model what it counts? Like, for example, if you had a text or a sentence or whatever, you would want to count words and not letters,
Yes.
and he would understand the format.
Yes, counter counts things in a sequence. And here I had just a very simple counter for letters, but you can do the same for elements of a list, which would be words. Or you could count the sentences and so on. So let me see. Let me write an example for you here in just a moment. I will check what's the value of text. Okay, so we still have our text. Let's convert our text to lowercase first, and then let's split our text into words. So result of this operation will be a list of words. Oops, sorry. What happened here? So here we take text, put it to lowercase and split. So a list of words. And now we can pass this list to a counter and return the five most frequent words in this text. So that is already a step towards what you wanted to do with counting words in a larger text. But now you need a way how to get your large file into Python, right? Okay, so let's look at that shortly. In order to move forward, I will skip the exercise for now, and I will aim to complete this notebook first. But I encourage you to look at the exercise, to write a simple number guessing game, and if you try that, we can help you with questions. So one final thing about Python libraries. So Python has many libraries in its standard Python standard library, the help for which can be found online. So different built-in types and whatnot. And then there are more libraries available which you can install separately. For example, there is a library called Requests, which lets you easily retrieve content from some web address. And sometimes these libraries are already installed in your environment. So Google Colab has many libraries available. But if they are not available, you can install them separately by using a command like exclamation mark pip install and the name of the library. That's it about libraries. Let me know if you have any questions. And let's conclude this notebook with working with files. So for working with files, let's first execute this part here. From pathlib import path. Then it's a question if you are using a local computer file system or if you are using Google Colab. Since most of you are using Google Colab, you will need to do some more steps to get access to files to work with. So the next cell here shows you the list of files in the current directory. But in case of Google Colab, there is not much. So Google Colab cannot directly access local files. So we need some files that we want to work with. Let's see how we can do that. So there is an icon called Files on Google Colab. And let me see if we can get a file called Alice in Wonderland, which I have already downloaded. If we can get it into Google Colab. And it appears that we can do that. So we need the file first. For the file, go to this GitHub address, BSSDH 2024 beginners. You had that address in your list of links for preparing for workshop. And download the text Alice in Wonderland. here perhaps you might need some help. But basically download this raw file to your computer, and then you can take this file, drag and drop it into Google Colab. Just a quick note, you will not need to execute. It appears that you can skip executing these instructions that say set false if not using Google Colab. So here you will probably need some assistance to get to the file, but I will show you the main thing to do is, so 2 steps. First step, you need to find this Alice in Wonderland file on GitHub. 3 steps. Second step is download the raw file. And the third step is in Google Colab Files icon, drag and drop this Alice in Wonderland text. And that should put the file on your disk. And you can check the section reading and writing files if you are able to access this file or not. So execute the 2 command blocks on reading and writing files, and you should get a result, something like this. So basically what we are telling Python is that we want to access a file called Alice in Wonderland in this path, which means dot, a current directory. And the current directory is what you have here in Google Colab. Yes?
Can it be any sort of file? Could it be like Excel file and the procedure would be the same?
Excel file, yes, it could be. But for that, you would need, so for Excel files, we will look at that when working with pandas, so that's tomorrow, where you can indeed work with tabular data. So Excel, separated values, and so on. Is it working for everyone? It's probably not, because I realized that I had to change instructions a bit. So once again, do not execute this part, this one node that is under the Google Colab node heading. You don't need that. Just pull the file into this local file directory, and you should be able to work with it. So basically, access the file in current directory, file named Alice in Wonderland, and execute this code block here, reading a file. So after you have done that, you should have access to the text. Okay, so this will be a note for everyone. Many of you, or most of you, managed to upload the file here to Alice in Wonderland, but we're stuck in the notebook itself. So one thing to make sure, under the heading of working with files, you must make sure that you import this path lib that you will be working with. So upload Alice in Wonderland file. Maybe that's a good idea to do that first. Then execute this from pathlib import path. Then list the contents of the folder. and print them in a nicer way. And you should see Alice in Wonderland here in a list of files. So it's important to execute these parts. Importing pathlib and defining the folder that you will be accessing files at. So do not skip these tasks. Then do not execute the cell directly under the Google Colab node, and execute 2 cells under heading reading and writing files. So here we define that we are interested in the file Alice in Wonderland, and here we actually read the file. So are there any issues where you can't work with that file? If it works for everyone, it's fine. If it doesn't, we can look at it. Okay, so it was important to execute those commands before, but now let's see how we can work with files in Python. We work with files by opening the files. And the open command needs a path to the files that we want to open. We have defined that already here. So my path, which is the current directory, and Alice in Wonderland.txt. And we give this open command also an optional encoding parameter because it's recommended to use UTF-8 Unicode encoding so that your text file can represent characters from multiple languages, including Latvian and others. And so the way how you open a file, usually you do that in a Python command with open file command as input file. And what this command will do, it will open the file and store a reference to this open file in the input file variable. Once we have done that, we can do something with the open input file. For example, we can use the method .read and opening closing brackets to read all the text in the file. And that would kind of answer also your question, how do you get a file? You open it, you read the whole content, and then you can do whatever you want to do with it. Count word frequency, maybe bigram frequency, things like that. And here, once we have done everything with the file, we finish the code block, which was defined here by using spaces after the with command, and we continue, for example, working with the text that we got from the file. What happens if you want to, at the end of your work, if you want to write a file? To write a file, you need some text or some content that you want to write, for example, text to be written to a file, and you open a file. Here I will use a pointer to the current directory and the name new file.txt, and you supply the second argument, which is W. W means write. So what we do in this command here is we open file for writing. So prepare file to be written to. And then we can refer to that output file with the method write and supply it the text we want to have written. And then, after that command is finished, let's just list the files in the current directory. So we will look at items in the current directory, in the myPath directory. We will sort them, convert them to the list, and print them out. and you will notice that we have a new file called newfile.txt. You don't see this file on the sidebar here yet. For that, we have to refresh the contents of the directory. And here you see that we have a file called newfile.txt. So that was the part about writing a file. Quite easy. Are there any questions about opening files, reading files, writing files? Well, if I were looking at the Alice in Wonderland text, I would have a question: how do you remove this Project Gutenberg header? Because really we don't need that header to work with text in that file. And here is a way, here is some program code with which we can do that. So we will create a new file called output.txt with the contents of our Alice in Wonderland file. So we will open the Alice in Wonderland file for input. We will open a new file called output.txt for output, and then just execute this code block. I will not have time to explain it line by line, though you can always ask ChatGPT to help that there, but let's just run it. Let's look at what is the file path. Okay, so that's actually not required, sorry. And let's open this newly formed file output.txt for reading this time. Let's read its contents. And let's print out first few characters of this file. And here we see that now we don't have the Project Gutenberg header anymore, and it starts directly with the name of the title and chapter or contents, table of contents of this ebook. And now it's a file, it's a task for you. Probably it will also stay as a task for you to do at home, is to use the counter class from the collections library to count word frequency in this file. So the result of executing this code here is in the file output.txt. One more note about using Google Colab is if you create some valuable data, so you do some analysis of your text and you save it to the current directory, so to this directory folder, to this folder that Google Colab provides you with, make sure that you download the data that you have worked with. For example, if I want this open.txt file preserved, then I'll press this icon with 3 dots and click download. Because after some time, Google Colab will switch off this remote computer that you are working with, and your files will be lost. So whatever files are important to you, make sure to download them. Google Colab will save these notebooks that you are working with, like day 1 Python introduction notebook here, it will save them on Google Drive, but just in case, it's also a good idea to, after you have finished working, to press File Download and download it as IPy Notebook extension. So download your work to be able to continue it later on. Are there any questions so far?
So now to do this task, we have to read this new file.
Yes. But actually, that task is already done, so the question is, we have to read this new file and how to do that. That task is already done here, where there is command with open mypath output txt with encoding UTF-8. We already instruct Python to open it and store a reference to it in the input file variable. And here, at this line, we read all the contents of this file. So the file has been read already. And you should have this code in your Jupyter notebook as well. So the file is here already. You just need to use the counter on this text, contents of the text variable. Does that answer your question?
Yes. And this task, is it a deliverable?
No, this task is not a deliverable. It's a step towards deliverables, shall we say. So deliverable, working on the deliverable will be a third part of tomorrow's workshop. But do this task because it will be required for the deliverable as well. So any more questions, comments? Sorry that we have less time than I hoped for, but getting up to speed does take its time. So thanks everyone for today's participation in today's workshop, and for everyone, also for people online on Zoom, we are taking a 10-minute break, and then there will be the open lecture, right?